feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. And I'm right where I belong in my happy place. And I'm right where I belong in my happy place.
Welcome to the National University of Singapore Yonglodin School of Medicine Healthy Longevity webinar. Thank you for joining us. Dr. Luc Aguilar is our guest, and we will talk about skin, about beauty, about longevity. Is beauty really related to longevity, or should we look more often in the mirror? I assume that this is going to trigger many questions, so please use the Q&A function to send your questions, your remarks, your ideas. As always, we are starting with a short presentation, this time by Sang Gwing, a PhD candidate at NUS, and she will talk about any-day modulators and what their potential mechanisms are of energy production.
Thanks for the introduction. Thanks for having me here to share my project with you in this webinar. I'm Qin Zhang, a PhD in CHL. My supervisor is Dr. Vincento Sorrentino. Today, I'm going to talk about explore the potential mechanism of energy production by NAD modulators. So first, what is NAD? NAD is known by people in two forms: oxidized form of NAD and the reduced form of NADH. Due to the conversion between these two forms, they are involved in a lot of essential processes in our body, including energy production, metabolic homeostasis, mitochondrial function, DNA repair, and so on. But today, I would like to highlight its role in energy production. So most of you may be familiar with this figure, the NAD-NADH cycle in the TCA cycle and the electron transport chain. Let me explain it a little bit to you. So the NAD will be reduced to the NADH in the TCA cycle, and it subsequently oxidized back to NAD by the complex 1 of the ETC. So after the complex 1 captures the electrons from the NADH, it will relay them to the coenzyme Q10 to relay to the next complexes, finally leading to the ATP production. So here's a small recap that how NAD plays in the energy production chain. If we look at the CoQ10, it behaves in a similar way like NAD. It can be found in both oxidized and reduced form also, and it's very essential cofactor in the ETC, just like I mentioned in the last slide. It could receive electrons from NADH complex 1 and the FADH complex 2. What's more, the declined NAD levels and the CoQ levels have been linked to aging and many other aging-associated diseases. So we cannot help but wondering, is there a new functional link between NAD and the CoQ10? The benefits of NAD supplements by its precursors like NR and NAM on the energy production across different species were shown by a lot of preclinical studies. For example, NR, a precursor of NAD, was given in the food to the young and old mice for 8 weeks. Then what they found is the oxygen production and the ATP production in old mice was increased a lot, even brought them back to the young mouse level. This was also seen in the C. elegans and primary human muscle smell tubes. So after giving the trigonolene, the other new precursor of NAD, to the muscles, the ETC complex activity of 1, 2, 3, 4 were increased. In another study of human brains in different age groups, they found that brain NAD levels were positively associated with ATP level and the rate of energy production. So all these findings together got us thinking, is there any potential functional link between NAD and ETC components? And if so, how is that relationship relevant to aging? To answer that question, we looked into the public transcriptomic dataset. So the first one is a naturally aging C. elegans dataset. For the mevalonate and tyrosine pathways, they are the upstream pathways for COQ biosynthesis to provide precursors for the COQ. We found that the expression of COQ biosynthesis pathways positively correlates with NAD biosynthetic and metabolic pathways. Next, we moved into the human transcriptomic data from GTEx. We did the same Spearman correlation analysis, and the results show that the same strong positive correlation in human kidney, liver, and muscle. The results in human data are tissue specific. So based on the data we found, we have the hypothesis that there is a functional link between NAD and the COQ. So we would like to test our hypothesis on C. elegans and human cells in the future. So that's all about my presentation. Thank you everyone for listening and watching, and especially thanks to our lab, Vincenzo's lab, and the BK lab. Special thanks to Professor Jan Gruber, RG, and Federico for being in my committee. Thank you so much.
Thank you for this great presentation. I think NAD precursors have great potential to modify human lifespan too, and you showed that. We are switching gears a little bit. We are now going to the skin. I'm very honored to have Dr. Luc Aguilar today with us. He is Chief Scientific Officer of Advanced Research at L'Oréal. With a PhD in molecular biology from Sorbonne University, he brings 25 years of experience across biotech, pharma, and cosmetics, focusing on skin biology and the science of aging of our skin. At L'Oréal, he has led global efforts in microbiome exposome research, shaping the company's innovation in biotechnology. Luc, it is an honor to have you here, and we would love to hear if skin is really so essential for health and longevity. Over to you.
Thank you, Andrea, and thank you for your kind invitation to give a lecture in your Healthy Longevity Seminar. And I'm going to share my screen. So longevity is about now understanding the root causes of aging at the biological level, and of course, anticipating the clinical symptoms before they appear. And we can wonder how longevity fixes here in this context of longevity. And it's a new era of skin research. And over the past decade, researchers have made tremendous effort in order to understanding all those hallmarks of aging, all those biological alterations. And I put it here in this good frame that with all those discoveries that occur, understanding the hallmarks. But if you look carefully on this frame produced by Campisi, skin has not been really addressed and is scarcely presented in all the studies, even though we studied mice, cells, and of course towards monkeys and human, skin is the big absentee. And that's why I'm going to share with you, even though it's, the skin is the way we are representing aging is not yet in the frame of all this research. So that's why I want to highlight here the need of studying skin and why skin. And skin, of course, is the largest organ in the human body. With 2 square meters, it has a dynamic interface between the environment, sensing it, and of course, responding to the body. And over the past years, researchers at L'Oréal have been, of course, constantly passionate by looking at, the factors triggering the biological changes and then the clinical changes that occur on the skin. By understanding all the factors contributing to those changes, what we call the skin exposome, basically. And of course, one of the factors we need to consider at first is sunlight, the UV light. And not only UVB associated with skin cancer, but also UVA. And I'm going to give a concrete example of that. But not only UVs, climate, pollution, visible light, so medical treatments. And these external factors are combined with other factors, the lifestyle, the sleep, circadian rhythm, the diet, the mental state, and of course, who we are, the skin phototype, the genetics, and all different hormonal status that may contribute with their specificity to the changes in skin. And all those factors altogether contribute to the biological change we are able to measure from the surface with the microbiome, the cellular activities, the epidermal renewal, melanogenesis, inflammation, towards, of course, extracellular matrix organization. And all those biological changes are impacting at the clinical level. So the dryness, the spots, the wrinkles. And the challenge we have is to make the connections between all those factors and the biological response. And longevity is for us a unique opportunity to make all those relationships in order to be more predictive when the molecular changes occur into the future and predicting the skin trajectories over years. And of course, we've been gathering scientific papers on all the different hallmarks of aging with more than 25 papers over the last 20 years. And I'm going to give you a concrete example of that. So first, the UVA. So as I quoted, is one of the most impactful factors triggering changes at the molecular, cellular, and then clinical level. We've been decoding all the biological hallmarks associated with the different UV lights. And I want to quote here the long UVA. So those UV represent 75 to 80% of all UV we are receiving. And those are constantly bombarding the skin from the winter, whatever the weather, from the summer. And those are deep penetrating the skin, even though they are displaying less energy. And we've characterized with 2D, 3D reconstructed skin towards predicting at the clinical level all the different changes and hallmark impacted by all those UV exposures. And this is, of course, describing mitochondrial dysfunction, cell metabolisms, and genomic instability triggered by these. Of course, UV give us a unique opportunity to develop filters specifically dedicated to protecting the skin from those UV lights. And for that, we really need to have a clear characterization at the clinical level. And we spend over the decades researchers to characterize exhaustively the facial aging, addressing visual aging signs at the standardized level. So we published the atlases in order to get access to all the different descriptors of the facial aging. We combine with the clinical expertise having dermatologists doing an evaluation, scoring deeply, not only cosmetic, but also dermatological treatments. And with this combination of the two, we are transforming, thanks to algorithms, thousands and thousands of images into a predictive tools in order to get access, instantly based on all the different exposures to the features of the skin at the current stage and for the next 10 years. And I'm going to give you an example here. So we are able to project skin trajectories based on the images we have collected and all the different impacting factors to collect exactly the feature and the future of all those clinical signs. And this is, we of course did the modeling systems with that. And thanks to algorithms, we are also doing it in an inclusive mode, targeting all the different ethnicities. And we know there is a big differences between Asian skin, a darker skin type, and Caucasian skin, for example, in the way they're aging. So at the dark spot level or in the wrinkle setup. So, and this gives us a unique opportunity to compare and to predict the efficacy of the different treatment, to see based on what they are protecting, what would be the level of protections, and then sketching the future of the skin, meaning, if you use a protection, we can give, of course, the benefits over the next 10 years on your face. But the key point here when dealing with longevity is to make the relationship between aging markers and biological markers and the clinical features. And this is we are doing through identifying these biological markers in order to get clocks. And clocks are very important, that has been extensively described, trying to make the relationship between the biological age and the chronological age in order to identify the biomarkers that would be the most appropriate associated with an accelerated aging or a decelerated aging, and more importantly, identifying the markers that would be associated with benefits on interventions. And of course, many clocks have been already published, and these are on the right side. And those clocks are been initially based on blood, and many of them are based on epigenetics and DNA methylation that has been really associated with an increased risk of mortality. But when we are dealing with skin, we do believe that we need to be at the organ level, identifying really biomarkers that would be the most correlated with the skin features today to get the biological status of any consumers and then projecting their skin trajectories. So we have for that look for markers that we can measure at the clinical level on the skin surface. And the first we were interested in is the microbiome. And we know that there is a change in the microbiome between young skin and old skin, with a loss of skin commensals that are crucial to keep the skin homeostasis, the staphylococci and the Cutibacterium. And at the same time, there is an increase in alpha diversity, meaning there is an increase in the number of different species we can see, with the aging. And this is, of course, quite important to see that these markers are really different. But what we want to do is a step further, showing the correlation between the biological markers based on the microbiome and then, the phenotype, the consequence at the clinical level. And we partner for that with UCSD, the Microbiome Innovation Center, in order to find specific signatures associated with the different clinical signs that we may see with aging, and of course, with the different grading and scoring. And this is, of course, one of the biomarkers we really bet for the future in order to get new clocks. And of course, there is another one which has been extensively studied from the blood, is the proteomics. At L'Oréal, we developed specific techniques in order to get access to thousands of protein by doing tape stripping on the skin surface in order to have access to thousands of proteins. And in this paper published recently, we ran a clinical study in which we were trying to match the clinical signs of aging with the biological features based on protein measurements. And over 21 clinical signs, different skin conditions, and with the overall thousands of proteins, we were able to identify a first set of proteins based on 5 proteins at the skin surface: lipocalin 1, filaggrin 2, the transglutaminase 3, and the insulin degrading enzyme, to be associated with an age acceleration. And this is a very starting important point in order to get access to new clocks. And for that, so what we deliver, and as we are a company, we wanted to get access to a huge amount of data, and we developed the first revolution, I would say, in the field of longevity science to get access to protein measurement to give a biological status for the consumers by getting access to their biological data in order to better refine the diagnostic and get access to a measurement signature that would give the individual their current biological status in order to give access to what kind of clinical sign a skin would be prone to. And this is, of course, the idea behind getting a first idea of the biological age and linked to chronological age based on the measurement of these 5 proteins and predicting and trying to intercept the aging signs based on these protein measurements, identifying a threshold by which a skin would be much more prone to skin wrinkles or to skin dark spots. And of course, we believe that the combinations of the measurements would be a much more accurate status at the consumer level. So we are matching the skin concern thanks to imaging with an infraclinical measurement on tone evenness, pores, dryness, wrinkle, to the cell bioprint, the measure of protein biomarkers, in order to, by combining the two and combining with a questionnaire, so getting a much more closer, accurate diagnostic of the skin of each individual. And of course, longevity for us means a way to be integrative in starting from science. So we launched the L'Oréal Longevity Integrative Science is the way we are addressing globally the status of each individual to propose a combined set of solutions for the consumers. And this is start with the biology first. And identifying the root causes of aging means identifying all biomarkers we gather here in a AI cloud. With all the omics data we have accumulated over years, we are able to describe precisely the different altered pathways that occur within the skin. And based on the biological status, then we are interested, of course, to measure the different alterations and the interconnections between the different hallmarks you see here in the different colors. And this is help researchers to design, of course, the best combo of active based on the alterations we are able to measure at the skin level. And this gives us then the opportunity to bring the combinations of solutions, starting, of course, with the diagnostic. And we believe that would be a combination from topical, devices, energies, supplements, and services at the end. So skin has to be seen as a whole. And this is really important, starting with the diagnostic. Of course, we are playing with topicals, but we are combining the different approaches to give the best proactive experience to the consumers in order to take care based on the diagnostic of their own skin. And of course, this is a strategy, we put it in place as a combination strategy and based on all the biological accumulation of alteration that start at the molecular level. We need to preserve all those alterations. And I talked about earlier on about UV filters, and that's really important to be added here at the first step. And this is a cumulative, of course, strategies. We're still preserving the skin all over the years while intercepting when we are able to measure cell dysfunctions. So either at the energy level and at whatever the cells from the top, the microbiome, the metabolisms, in order to be even more proactive in intercepting the cellular dysfunction before the tissue at the end will be impacted. Well, when at that stage, we believe we need to reprogram, reset, the functions in order to have back again the cell and the tissue decline offset. And this is, of course, we are gathering all the different active ingredients we have developed over years and making the link with the different hallmarks of aging. Here you can see we identify 9 hallmarks of aging. We believe those are the ones that today, with the current scientific knowledge in the literature, as the most appropriate to be linked to the skin functions, and trying to make those connections between the different hallmarks and with all the cloud of the different pathways we are identifying, we will propose the best association in order to, of course, address each skin at the right level where they stand when we are measuring and diagnosticating, doing the diagnostic. But I want to highlight a new way to see the skin. Skin, as I quoted before, is sensing the environment, but also responding to the body. And we believe skin is also a mirror of the health of the different organs in the body. And for that, I will give you concrete examples. So on the connection between the skin and diseases linked to skin alteration. So first, I will quote, of course, the link between the bone and the skin through the vitamin D. As you know, vitamin D is exclusively produced in the organ in the body by the skin, thanks to specific UV wavelength exposure, triggering the synthesis of the vitamin D. And we know, of course, there is a loss and a higher risk of bone loss and bone loss when there is a deficiency in vitamin D. And concretely, there is many more examples making the link between skin and the different organs, the gut, the heart, the blood, the muscles, and the hormones. And I will give you here 3 concrete examples. First, there is more and more publication linking vitamin D to all cause of mortality. And the higher the level of vitamin D, the lower the risk of all-cause mortality has been shown recently in this publication. And more importantly is how we can use the facial features in order to predict some risk of age-related disease. And these publications are quite interesting to see that the facial features are predictive of increased risk of osteoporosis and memory decline at the same time. And more recently, from these correlations of observation, so this paper on skin senescence and cognitions were quite interesting to quote here in this discussion. So by transplanting senescence fibroblasts compared to proliferative fibroblasts, there were an increase in P21 biomarkers in the hippocampus of the mice. And that was quite interesting to note that this was linked to a change in memory decline in the different tests on behavioral tests as seen in the backside. So that was quite interesting to see to what extent we can make the link between the skin and the brain in the future. Finally, I want to end this presentation with the need of more research and research opportunities in order to get a bit further on the link between skin and longevity. The first is we crucially need more validated biomarkers. So we do have a set of biomarkers, and we need a large amount of biomarkers in order to be more predictive in the future of each of the skin based on the current biological status. And more importantly, we really need to identify biomarkers that are really linked to skin responses at the end. So to see from interventions, so what would be the biomarkers that will be a responder in the different studies? And of course, on the other way around, so medical field is going fast in testing new molecules, and we are also pushing forward to see to what extent those molecules tested for age-related disease would be interesting on the skin features as well, and particularly around mitochondrial dysfunctions and on senescence. So with senolytics and xenomorphics, we do believe that there is a way to show and to prove the importance of skin related to longevity. So this would end my talk. I hope I have convinced you to use skin as a way to monitor not only skin changes over years at molecular and the clinical level, but also entering a new space of using skin as a way to monitor our own body health. And thank you. I want to thank you here, of course, all L'Oréal team in gathering all those data for this presentation. And of course, the NUS team and you, Andrea, for inviting me again for this lecture. Thank you. Thank you again.
Thank you so much, Luc. Wonderful presentation and congratulations. really on how L'Oreal is driving the evidence-based skin research and bringing more products on the market and learning what the role of skin is. May I ask you the first question? I think there's always the discussion how much sun exposure is good for you, because your first slides were about UV light, and it was really put into the light of being negative. But you also said there needs to be vitamin D metabolism. So where is the trade-off? Can you enlighten us?
Well, of course, today the risk of following chronic sun exposure is quite well demonstrated and linked to cancer on the long term. And that's really well demonstrated in Australian studies and all over the world, the tight connection, not only on UVB, but also UVA light and the need of protection. And the cosmetic industry is committed to provide the consumers the rights, and photoprotection is really the first concern that we are making here. And there is also a consensus paper released by derms on the impact of vitamin D related to skin, this is your question, because vitamin D is really produced by a small amount of UVB light. And today, the consensus stated by those derms that there is, of course, there is no impact so far based on the normal exposures. The normal minimum 15 minutes exposure is enough to trigger the vitamin D synthesis. And this consensus stated that there is no impact of photoprotections when related to the time and the sunlight needed in order to trigger, the vitamin D synthesis. And of course, only those staying in the really north part of the globe that may face, because of their overall very low exposure, and that would be a recommendation to have a supplementation on vitamin D supplementation on the winter time for those zones. So basically, this is where we stand, and the risk has been, it's much higher, triggering biological and clinical alteration, getting to the cancerization at the end, than, of course, the impact on the vitamin D synthesis.
So 15 minutes of how much surface? Because I looked at your products, and these are especially the face products, and they all have the protectors in there.
It's face. Yes, this is face exposure. Yeah, face and arm. That has been, because of course during winter is only face exposure. So.
Okay. 15 minutes. Let us switch the gears a little bit. You showed a very nice slide about the aging trajectories within two women, I think you showed. And it seemed that this is linear, the relationship with chronological age, how aged you actually look. If I look back and I had life events, for example, people would say to me, hey, you look really not good. So they say you are looking really, really old. So is it a linear relationship of how much bouncing back is it from one age to the other? And why is that? Is it just dehydration of the skin, or is our skin really bouncing in biological mechanisms?
No, it's well, I won't say this is linear for the purpose of the explanation. I put it in a linear way, but of course the change, the apparent changes, is very linked to the level of exposure. It's not, you can have at 35, 40 years old people with very different skin phenotypic features. And this is really the results of the different exposures, basically, not only, of course, UV exposures, but also the way they live, the pollutions, the diet, and all in all, so this will contribute on the accelerated aging. Of course, as we did for the clock, we are measuring in a mean of populations and then looking for those that are far from the mean in order to qualify what would be the factors that would be the most contributing to the change at the facial level. So this is really the difference. And as you know, there is a recent paper showing that there would be, moments in life that would, at the biological level, would be trigger higher change occurring 40, 45 years old. So we do see change at the clinical level occurring at that moment, but we do see even more changes following the different level of exposures. And of course, photoaging, you can see it as early as 35 years old, and with very huge clinical changes compared to overall population.
Okay, so what is the genetic component in that linear of non-linear relationship then with chronological age? Sometimes you see individuals, and then at the age of 40, at the age of 30, they were really having a nice skin, and then at the age of 40, many wrinkles without that exposure. So, and it seems it runs sometimes in families.
No, that's a very good point. And based on what has been published on the twin studies, as they share really the same genetics background, so we assume today that about 70 to 75% of your skin appearance is really the results of your exposures, basically. I would not say only sun exposures, but global lifestyle exposures, sun being one of the most heavily contributors, of course. And for the rest, genetics, of course, is the way, this lifestyle will answer. So, and that's why it's about 20%, 25%, of course, of the overall response in each individual. So far, this is, cohort studies that tend to qualify the contribution of genetics versus lifestyles, epigenetics being part of of course, not genetics being modulable somehow, so being part of the resulting from the exposures.
Yeah, so it's roughly the same as for the prediction of lifespan. So there we also say it's 20, 25, something 30% of genetic contribution. Okay.
Yes, which is great. Putting the skin in the same frame of all the other organs when dealing with aging. So that would be a way to use the skin to see to what extent measuring this contribution to exposures is reflecting the change in other organs at the same time.
Okay, thanks for that. So that was my next question. You really now in our field have the evolution that we think, okay, the pace of aging in different organ system is different. So now we have proteomic clocks which say, okay, you are a heart ager, you are a lung ager, you are a brain ager. In all the publications, I haven't seen the organ skin yet.
Yes.
So I think that's a missing link, and you are capturing that very likely. What is your hypothesis? Is the concordance or the disconcordance within individual between the different organ systems greater or lesser if you're looking at the skin compared to other organ systems?
Well, that's a great question. It's hard to answer as we don't have yet any data making the link between the different organs and the skin. And of course, so far, we even, so far all the connection between the organs has been done through the blood, basically, trying to identify specific signatures from the blood coming from the different organs. So we can even think a bit further. So looking for making the connection between all these blood proteomics linked to organs and then proteins directly coming from the skin, because skin has the uniqueness to be at the external side of the body, and sampling is quite easier. So we cannot do that for as easy, except blood, which or saliva, but all the other organs are cannot be easily sampled in order to make these connections even accurate, to see concordance or disconcordance on that. So I do believe new body of research will, in the future, answer more deeply this question.
I fully agree with you that academically it might be very nice to know, but let me challenge you a little bit. If I look at the heart and I detect somebody who is a heart ager and then providing therapeutics that person is not dying from heart failure or from lung disease or from Alzheimer's disease and suffering from it, what would be the clinical consequence if you would be a skin ager, except of that you would look older?
Well, that's the way we need to enter, and we do believe that because, of course, skin is the blood is innervating all the organs, including skin. And the way we should answer this question is we believe, by identifying as early as possible the biological damages that we can see even from the skin, would be interesting to track future functional impact, as you are proposing here from the heart. Because when you are measuring hertz and heart decline, so I believe it's not the results, it's a result of loss of whatever resilience or biological alteration that have been accumulated in the organ. And let's imagine that we are able to measure this at the biological level within the skin, as we can do that for vitamin D, for example. What should we wait for, measuring bone loss far before, by getting access to a threshold within the skin that would predict, the trajectories of your bone loss in the future. So this is, of course, as skin were not at all studied in the past, included in all those studies. So it's hard to tell it. So my point is quite easy to sample at the skin level. And I would tend to say any teeny changes at the biological level that we can measure on the skin that would reflect a future, organ decline elsewhere would be, of course, a change in the way we measure it, not only through the blood, basically.
Yeah, great. So really looking at as a biomarker of aging, predicting the future at the inner side. I love it. Could we use the skin as a gerotherapeutic to make ourselves younger from the inner side?
Ah, wow! That's the connections of, at least from the mice studies. Well, that's something promising in the future. So I would tend to, and I hope we're going to get this answer. Either testing, drugs, geroprotectors from the inside to see to what extent they're inducing change at the skin level, which would be the reverse. But also, from the other way around would be really nice, trying to, we do believe, because of the biological alteration, and we saw this from the hormonal standpoint, as you know, skin and brain are coming from the same origin and are responding to different hormones. And there is several papers showing, how hormone produced at the skin level impacts then after at the brain. Of course, these are animal studies, but that would be fantastic that acting, of course, at the skin level, we are impacting, far beyond the skin overall, on these organs.
Great. We really have to go through all the questions of the audience, and Sandra Jose is leading that in a second. I have one short question for you. I would be very curious. We are doing the talent incubator at this moment in time. All the young talent said, hey, you do the webinar with Luc Aguilar, and ask him, what kind of characteristics of young talent should they bring if they want to have a career at L'Oreal?
Well, that's a very interesting point. So we are hiring, scientists from all over the world, including from Singapore, of course, where we do have joint labs with academic partners there. And what would be, I would tend to say, be curious first. So be interested and curious as a scientist, open to discoveries. So, and what we have here in common in L'Oréal as researchers is the passion for skin and hair, first as an organ to better understand, because this is something visible, but also through the invisible side. And then, yes, the passion for research. So basically, this is the two advice I would give to your students if they want to, of course, bring their skills and talents within L'Oréal. And as you might know, this is we do have in advanced research more than 650 researchers, and at L'Oréal, we are hosting 4,000 scientists all in all at research and innovation. So there is many different expertise and many different ways to develop ones in the L'Oréal research, be part of L'Oréal research.
Thank you. Over to Sandra. There are lots of questions.
Thank you so much, Dr. Luc. It almost sounded like a professor talk. Yeah, for that enlightening session. I'm Sandra Jose, a PhD student at School of Medicine, and I work on longevity science at the intersection of computational and pure biology. I'll begin with one of my own questions because it's pretty deep, although skin is on the surface. Dr. Luc, based on your journey from your PhD to CSO at L'Oréal, and tremendous experience with scientists and customers, do you think self-care, especially skincare, can help people move from just thriving to like truly enjoying the process? And can that have a positive impact on brain health, mood, and even support longevity in a more holistic way? Meaning, like, can skincare be a pleasure or a pressure?
No, and I have to remind, of course, beauty has been in the heart of all civilization for the past, in the entire humanity. And beauty, it goes beyond just how I look. It goes with how I function, of course, as we were speaking about biological alterations and the way the skin is functioning, but it's how I feel. You know, there is a, you know, when we used to say that when there is a really stressful moment and period, the time by which you can take care of yourself through beauty routine is really essential. And we do believe those, of course, the routine and aspects of the way we are using beauty is an essential part of our own humanities, and skin and the way we are appearing to others is through the face, and we know how important is the appearance when dealing with our own mood. And if you are acting on the feelings, then you are acting on your global organisms. And at L'Oréal, we even have a cognitive labs, to better understand all those connections that are really critical to make the link between, the feelings that people experience with beauty products and then the way they feel after these applications. So we crucially believe that beauty is an essential part of humans. So that's really important, that it's not about superficial, gestures. It is about taking care of yourself somehow and the way you are projecting to others.
Exactly. Yeah, that's recently it's just that I started my skincare routine and it feels great. Like just on the day one I felt, so there's this process of lymphatic drainage and this and that. Somehow everything gives us a better feeling of what we are. Okay, now we move on to the questions from the audience. So we have one of the very important questions: where do we get the L'Oréal skin aging tests in Singapore?
Well, the cell bioprint have been released to the CES, the big tech show in Las Vegas, early this year. And we are in pilots to launch it through the brand, which would be Lancôme. and that would be early next year. So that, and when would be in Singapore? Let me check that, and I will revert with the answer. So I'm not sure, today where the launches will be at first.
Okay, great. We are all eagerly waiting for it. And we have another question. So, given that you have research and data, shouldn't the brand also play a role in reshaping the public perception by highlighting skin as an essential organ?
Absolutely. So that was basically what we believe, and to that we need to show through science-based evidence that there is a deep connection between skin and the other organs, and basically impacting health as a whole. And that's why we are entering into partnerships in order to go into that direction.
Great. So we have another question where, from a consumer level, what advice would you give to choose effective skincare products backed by science?
So that's, I have to say, the first questions I always have within my talks. So, of course, as you probably have captured in my talk, photoprotection would be the first gesture that you should apply if you need to take care of your skin. Because, if wherever you are in the world, you're going to be faced to sun exposures. Of course, according to who you are, and according to your phototype, so the skincare routine would be slightly different. But of course, photoprotections as a whole, and then we would have to deep dive into, according to your, the tone of your skin, that would be different. But that would be the first. And the second is moisturizers. So of course, this is the two that need to be done in this pace of longevity, for example, and without any apparent, skin concerns, basically. So of course, then whenever you are having a skin concern, you will have specific skin routine that would be applied. But in a whole set, all the products we are developing are backed by science. This is really, and the big innovations we are pushing are really the results of all the investment L'Oréal is doing at the research and innovation level. So contrary to other, we are spending, about 4% of our global turnover in research. And this is the highest percentage in the cosmetic industry. And finally, I have to say that we are in the cosmetic industry having what we call advanced research, the most powerful research entity that is really dedicated to understand through science, skin and hair, to develop the products that are really based on those science.
Great. So, long story short, will be the skincare based on moisturizer and photoprotection, right? Okay.
Right.
Yes. So we depend on you for backed science.
I'll give a personal advice then after.
Yeah. Thank you. We have another question about the skin microbiome. Can you suggest healthy longevity literature related the skin microbiome handling? I would like to use it for explanation of the importance of skin microbiome to normal average audience.
Well, so this is, let's say, a microbiome is our ecosystem that sit on the skin surface, and it is really important to ensure the skin homeostasis, the skin balance, basically. And of course, these microbes have been associated to skin immune dysfunctions and skin barrier impairment. At the same time, there is a lot of data showing the importance, and specifically in those that have skin microbiome disbalances. And I'm going to give a concrete example in atopic dermatitis, in eczema, for example. So while we know there is a quite heavy skin microbiome imbalance, and where we know the skin microbiome is directly linked to the skin features. So this is really important. And I know explaining microbiome microbes, and especially in our Pasteur here in Paris history, we have been used to associate microbes to bad guys. And here explaining to average people is that we need basically we are not alone when dealing with in our skin, and actually we have more microbes than human cells sitting in the body globally. So that's really important. That's not taking care of these set of microbes, and explaining it easily. It's we are hosting 1,000 microbes per square centimeter on the skin. So that's quite easy. And those are quite important and are part of us. And this is basically, maintaining a healthy one, and at least linked to disease is quite well demonstrated, linked to healthy state of the skin. This is currently the progress and the research we are conducting in order to make this relationship from correlation to causation.
All right. So it seems like an area which needs more research on.
Well, it's quite new. Basically, if you think about gut microbiome, which is the one is the most advanced, so today there is one drug on the market, the FMT typically, and so far there is a lot of clinical studies ongoing from phase 1 to phase 3, but not yet many different products and drugs on the market. So that's quite important. It's about 10 years research area, basically a bit more, 15 years, let's say, at least for the skin.
Got it. We move on to the next question. Any data on senescent skin cells having systemic or negative health effects, maybe even precancerous cells, skin cells having negative systemic effects in terms of longevity?
Mm-hmm. Well, we are, as you know, there is a few senescent cells in the human body, and we are currently characterizing those senescence profiling, the SASP, and thanks to all the latest techniques, these special transcriptomics, we are now able to reach this kind of precisions in order to really get access, making correlation first between the descriptions of those senescent cells that sit within the skin, and what we are looking for primarily is what they do at the skin as an organ per se. And of course, if you base on these recent publications of in Nature Aging, we have to then see to what extent what they secrete being there is impacting the surrounding environments that we believe in, and this has been published, but also impacting at distance what may occur then later in a distance way. So this is, to me, is not yet addressed.
We have another interesting question on nanotechnology in skincare. Where do you think nanotechnology can play a role in delivering of the anti-aging skincare products, and what are the challenges in this area?
Well, when dealing with cosmetic, nano is never a good path because of all the concerns that would be related to nano dimension. But of course, tech is a quite important path. We do believe, of course, in formulation, for example, using technologies that will help getting through the stratum corneum, or delivering differently active ingredients, drugs, would be, of course, of interest in anti-aging and in skincare products. So, but nano, because of the old regulatory wise in cosmetics, this is always a concern and need labeling. So this is really important that we consider, the regulatory landscape before going into, transforming innovations into the business. So, but yes, we do believe nanotechnologies and technologies more globally are quite interesting in terms of bringing disruptive innovations.
We have maybe one last question about the brain-skin axis. So does that exist, and how do you think about what comments do you have about brain-skin axis?
Well, this is at the very beginning. There is recent papers showing, different stuff. What we aim to do is finding what would be the biomarkers that we might identify in brain disease conditions that may be of interest. And this is something that we are starting only. And we do believe that we need to start with, identifying biomarkers linked to clinical features, or at least in conditions where we know there would be brain diseases afterward, even though there is not yet any symptoms, and trying to find, biomarkers that would be of interest from the skin that would make the link. So there are several papers popping up right now linking microbiome with. But these are I believe we need more data in order to make these correlations and these evidence-based science around the connection between brain and skin.
Can we end with one last question about your personal skincare routine?
Okay. Well, as you mentioned, I have quite. I'm a phototype 3 as a skin tone, so I'm wearing every day, all year long, the photo protection at first, and then of course a deep moisturizer. So I won't tell you any brands here, but deep moisturizer, meaning high content of glycerin, so that's really important. And then as I have some dark spots, so I'm using some molecules that are really linked to hyperpigmentations. And here, of course, we do have, I don't want to offend any of our brands, but of course, you have dermatological brands, from SkinCeuticals in the US and La Roche-Posay, which have tremendous, of course, products. And of course, here we can quote, we do have developed for hyperpigmentations, the Melasyl, which is really the trade name of a very different anti-pigmentation, anti-hyperpigmentation following sun exposures or even following over pigmented lesions. And of course, if I need to quote one brand I'm wearing every day, is Antelios from La Roche-Posay, because this is the only filters having the long UVA protections that, of course, help protecting, the full spectrum of UV exposure, even in a cloudy time, all over the year.
Wow. I will not ask what kind of longevity treats others otherwise than treating your skin with some creams you're doing. That's the next time.
Okay.
Thank you so much,
Thank you
Dr.
so
Aguilar.
much.
It was
you.
a pleasure, this conversation. I hope you as an audience, you enjoyed as I the conversation. Please use the chat function to leave your suggestions, your comments, your feedback, maybe your skin therapy you are providing every day onto your skin. We at the NUS Academy for Healthy Longevity, we are recruiting for participants. I brought 2 studies. The first one is targeting SIRT6 pathways with brown seaweed. Yes, with seaweed. We are including 50 to 80-year-olds and only male. So if you are living in Singapore, you are 50 to 80, or you have a neighbor or a friend, please let them know while scanning the QR code, which will be shown in a second. There is another one. We have Sedira. Should you take multivitamins? In Singapore, more than 60% of individuals take multivitamins and minerals regularly. Is it helping? We are including 40 to 60-year-olds, biologically older than the chronological age, and we are evaluating the role of multivitamins and minerals on aging processes. These are the 2 studies brought for you. I have another announcement. There is a new webinar structure starting in August. We are changing gears, we are evolving. We are starting from August onwards to adapt a new episode format with 2 episodes every month. The first and the third Thursday, same time, 7 p.m. So please be sure to register to our webinar and receive the latest schedules. For July, everything remains unchanged. That's also the reason why I am now announcing the next Healthy Longevity webinar that's on the 17th of July. And my dear colleague and friend, Professor Heike Bishop-Ferrari, will be the guest. And I think she will talk about the Do Health study. We are, as always, closing with a final video, and this time showcasing you why we are so proud to work at NUS, celebrating our 120th birthday. Take care.
The school has this mission to create solutions for the health and healthcare challenges that Singapore faces. And the only way to create solutions is through research. We cannot just be constantly using existing knowledge to treat our patients.
The research that is being done in the university is quite mind-boggling. The research in longevity and the life sciences, it completely takes my breath away.
Research makes for better healthcare. Medicine is transforming every day with new hypotheses, new discoveries, advances in technical capabilities. All these present new opportunities for improved treatments and to make care safer, more cost-effective, more accessible for the benefit of our patients.
Today, the school has established 10 translational research programs and 15 faculty research centers across several different fields, including healthy longevity, human potential, Asian women's health, digital medicine, and behavioral and implementation science interventions. Among these was a bold new initiative to transform clinical practices and healthcare.
I'm feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down.